So as a test of the IA criteria and a new IA, this is a little diary of the production of an IA, obviously by a teacher with a bit of help from the students, just to see how many words it takes, how long it is, and what's the challenges. So of course there are 4 criteria in the assessment criteria now: research design, data analysis, conclusion and evaluation, and each of these criteria have a number of different elements to them. So I've numbered them here: research design 1, research design 2, research design 3, and then data analysis, etc. And there are 10 of these altogether. So it's quite useful to know that at the beginning, because of course the IA will include all of these elements, or it should include all of these elements. But of course the process of doing an IA is unlikely to follow the assessment criteria in just this way. So all the sections that you have to do, I'm going to describe how I've done this IA, and they will end up in a report which puts them into the correct order for assessment, but it may be that we don't follow that order exactly. In fact, it's quite likely that we'll do the introduction or finish the introduction, close to the end of the writing process, so that we can be sure everything that we put there is relevant. So what do you do at the beginning? The first thing you have to do is to think of an interesting topic, and perhaps I'm a bit more used to thinking about biology topics that might lend themselves to an IA than the average student, but let's just imagine I've been running and I'm interested to know why people put their hands on their knees at the end of a run. Does it help them breathe better, or are they just tired and it's a more comfortable position to stand in, or is it just something people do and it actually doesn't help them very much? So this is my question, and I'm thinking, could this make an IA? So what do I have to think about in order to decide that? Well, first thing probably is to think, can I test this idea in some way in the lab? So is there some apparatus I could use that would help me to answer the question? And I haven't really got a research question yet. I'm just interested in this problem of, if I bend over when I'm trying to breathe fast at the end of running, is it better, or should I do something else? And in fact, we've got some apparatus in school that we can use that might help, like a peak flow meter, you can see on the left, and the spirometer bag, which measures the total lung volume, not total lung volume, obviously there's a reserve volume left behind afterwards, but it measures the volume of a large breath. So that could be used to measure whether leaning forwards allows you to have a greater volume in your breath, and the peak flow meter could be used to see if leaning forwards means that you can breathe air at a faster rate. The flow rate would increase perhaps in that position. So it looks like we've got some apparatus, and so there's some collaboration allowed in the IA, and in groups of 3 students can think about what could you do with some apparatus, what variables could you measure, how would you best set it up, what are the practical difficulties, what's the uncertainty of this particular piece of apparatus. Would it be better to use a different spirometer for measuring flow rates, or is a peak flow meter enough? Could I do something differently? How many different bending angles should I use? There are a whole lot of questions that are quite complex at the beginning, and this is an area where there can be some collaboration with small groups of 3 students can talk about the variables, and so that's what I did. Students grouped into 3, and they discussed, what would be a potential independent variable and what would be a potential dependent variable using one of these pieces of apparatus. And I gave the students the choice, which would they like to look at, and this is not really a real IA, this is just a little practice of my idea. Can I do an IA in this way? Does it work? Before the students are going to start the real thing. So we just had a little look at this as an idea. And the students found that it was quite easy to come up with quite a lot of variables, and some of them came up with better ones than I'd thought of. For example, the position of your head might be more important than the bending at the waist, or maybe if you lie on your back it's better than lying on your front. And you do see sometimes athletes lying on their back on a running track at the end of a run with their arms outstretched. So perhaps your arms outstretched is helpful, or maybe it's better with your hands on your chest. Do you know, there are all sorts of different things that came up. And so all of the leftover variables, once you've decided a research question with an independent variable and a dependent variable, all the leftover variables could be considered, and you could ask the question, are they potentially variables that should be controlled during the experiment? And so once we've brainstormed things, students can individually come up with a research question using 2 variables from this list, and then they can consider some of the others, but this they have to do on their own and worry about the controlled variables and that sort of thing. So from that point onwards, we've played with the apparatus, we've thought about the variables, we've even considered maybe some of the difficulties of using the apparatus. Now is where it becomes individual. So the students have to work out for their particular research question how many values of the independent variable will they actually use. And in this IA, I decided to keep it very simple because I wanted to do something quite quick, and I set myself the challenge of, in one lesson, collecting the data with the students helping me, and then I promised the students I would write up the IA over the weekend so they could see on Monday what an IA might look like, and I said I would explain this process to them. So how many values will you need? I'm going to keep it simple. I'm going to have 0 degrees of bend at my hips and 90 degrees bend, a little bit like the photograph we saw earlier, somebody with their hands on their knees or their elbows on their knees at the end of a run. That's about 90 degrees. And we're going to just test those 2 values of the independent variable. And now we want to get as many repeated values as we can. Ideally, I'd like about 20 pairs of values, with individuals measuring the volume of their lung breath or the largest breath after being in that position for a moment, and then bending over, being in the sort of 90-degree position for a moment. So that would be ideal to have about 20 results, because then we could look at a statistical test like a t-test, and it would give us quite a reliable measure of the probability of getting these data if there is no real difference. The null hypothesis is true. So that's what I'd like, but I may run out of time in the lesson, so we'll see how far it goes. I need to write down the research question too before I forget. So I tried to write down the research question. You can see it in the document. It does the position of the torso in relation to the legs. And I'm calling that the hip bend angle, measured in degrees using a goniometer. Affect the vital capacity of the lungs, measured in litres using a lung volume bag spirometer. And we've got these bags, you blow into them, and it gives you a measure of the vital capacity, which is the volume of the lungs minus the reserve volume, which of course you can't breathe out because you've got a rib cage that's holding a little bit of volume inside your lungs all the time. So that's how that worked, and I needed to think, how are we going to do this experiment? There needs to be some sort of practical step-by-step method. So a little pilot study with the students in the class tested whether the apparatus worked and if the students could use it, and we got some readings. If you're going to collaborate, you have to say which students did you collaborate with, and you can use their student codes rather than their names, because that maintains some sort of anonymity. And you say what you did with the students a little bit. So I've done this in my pilot study section of my report. You can see that in the report. And I've also established that the machine will measure accurately to 0.1 litres of volume, which I think is probably accurate enough for the measurements we're going to do, which seem to go between about 2.5 litres and 4.5 litres, depending on various things about the experiment when we tested it. So I've written down a little step-by-step method. I've included something about the control of temperature in the room, because I think that might have an effect on the way people breathe and the volume of the air. I've said a few things about standing calmly, so there's no extra changes to the heartbeat or anything like that that might affect things. And if I was really writing this as an IA, I would probably take a bit more time to spell out some of the control measures that I've used, how many repeats, and I might justify the range of values. Why did I choose 19? I'd write that down in a bit more detail than I have. But anyway, I've done it nice and simply. I think you can follow it. It's perhaps a little bit less detailed than it would be ideal to have, but not too bad. And then we need to think about risks, of course, as a teacher. We do that every lesson if we're doing an experiment, but students need to do that too. So here we go. I've considered hygiene. We don't really want everybody using the same bags and swapping them around without washing the mouthpieces. We need some sterilizing thing of some sort to make sure the mouthpieces are washed and sterile afterwards. We don't want to damage the environment by putting bleach down the sink or something like that, so we need to be careful to follow the waste procedures. I've got this nice biodegradable sterilizing solution, which is not made with bleach, and that's safe to use. And we're going to anonymize the results, and I should have included a consent form really, although in my lesson as a teacher the students' consent to come to school, I guess, is part of it, but for the IA you would really want to have a consent form. It's good ethical practice, and something that I've omitted here, which probably I should have done, or definitely should. Okay, so now we've got the method, we've written down a risk assessment, we should collect the data, and I haven't worried too much about all of the theory at the moment. I've got some ideas about why might it be that if you bend over it stops you from breathing so much, or it helps you to breathe. I'm thinking that maybe if you bend over forwards, your stomach and your liver might push against the diaphragm, and that may prevent you breathing in as much as you might breathe in otherwise, so it might make it harder to breathe if you breathe over. But I have seen in one of the books that actually leaning forwards helps your ribs to move, and actually helps to support the abdomen muscles, which are pushing the air out of your lungs when you breathe out. So that might actually help. So there we go. So we've got some carrying out to do, and I've encouraged my students to write down any observation. Any observations that they have while they're working. Excuse me. So here's the data. We managed to collect 9 pairs of data, but one of them, the students did something silly, didn't empty the bag in between the reading. So we've got one reading of 6 litres, which was far bigger than any of the others, and the bag obviously had air in it before the second experiment had begun. There was something went wrong, so we're going to discount this this third reading for the participant A. And in the table of results, which I've created here, we need to have the detail in the title, exactly what are we measuring. We need to have units, we need to have uncertainties, and we need to make sure that the data is anonymized so that we're compliant with ethics and the guidance that the IB gives for experiments. So now the lesson's finished, I've got the results, and I'm playing with Excel a little bit, and what I've got to do really is to find out from the results, have I got a trend of any sort. So I'll just go back if I can to the results. It's going to show us that we've got the mean value of 3.2 and 2.8 when you breathe forwards, which tends to confirm my idea that maybe it's more difficult to breathe if you lean over too far forwards. We've got more than 5 results, so we could do a standard deviation according to the guidance that the IB give us. And so I've calculated a standard deviation, and I plotted a graph with standard deviation for each bar taken from this, a custom value taken from this calculated value. And I've used the formulas, I've explained it here in the data analysis section of my write-up, and I've included the graph, which I've tried to put grid lines on and make it look clear. I've got the same number of decimal points in my axis as I have in the uncertainty value, and my mean also has the same number of decimal points, and so does the standard deviation as the uncertainty value, and that's not a bad thing to do. Once we've got a difference, like it seemed like there was a little bit of a difference, we need to test it with some sort of statistical test. Now, a t-test is a good test to use if you've got two means and you've calculated a standard deviation. You're assuming it's normal distribution of values in each of the sets of data you've got. I've only got 9 repeats, so it's a little bit of a small data set, but 5 is the minimum to do a standard deviation according to the IB guidance for biology. And I know the maths teachers at school would much prefer us to have 20 sets of data if we could, but there we are. It's not perfect, but we're going to do a test anyway, and the probability that I get when I calculate the test is this is the probability that we've got this data, but the null hypothesis is true, and the null hypothesis is that there is no difference between the volume of air breathed in the two positions. And you can see that the test results here 0.047, which gives a slightly, well, just a smaller value than the critical value, 0.05. And I've given an extra decimal point here because if I don't do that, you can't see that it's 47. It'll look round up to 0.05. And I think that's quite important at this point. And so I think that's perfectly okay to do. You could say adding a decimal point or even 3 significant figures might be good and possible. So that's very good. I've written a description about this, and you may notice that at the bottom I've got a different t-test result. And what I have done actually is I've looked at my data and I added some extra data to see at what point would the test become significant at the 0.05% level. And the original data that I had, which actually had 8 values in it, I think gave this value of a t-test. So the value I got for 0.047 actually had 4 extra values added to make 12 in total. And I wanted to see that was the smallest number that gave a t-test which was small, with a probability smaller than the critical value of 0.05. So at the significance level of 0.05, sorry. So I was just playing with the data to see, you know, how close was my experiment to being a good one. That's not something a student should do. You should certainly not add made-up values to your data, but to record some extra values would be a good thing to do if you find that the data didn't completely work, and you've got time to do that usually. If you know what I mean, if there wasn't enough data for the statistical test to work very well. Especially here, we wanted to have 20, but we only had 8. It's not really quite enough, so adding 4 more pieces of data would be a good thing to do here. And then wrote a conclusion. I referred back to the research question, included some theory about why the bending might affect the breathing, and some references and some citations. And then I went back to look at the introduction where I'd put a few images in and some ideas about bending and some things about the equipment. And I just made sure that the things that I put in the introduction were relevant to the exact research question there. I used the tool in Word to do my citations and references. You can change the style with this tool. Simply add a source if you want to insert a new source. So if you've got a new one to add, and it creates a little list here. I've got 4 sources that I've used in this IA, and if I wanted to put a citation to one of these references at any point in the work, I could just click Insert Citation, click on the citation I want to insert, and it will put the brackets and the formatting for me. And then at the very end of the document, I click on Bibliography, and it will insert all of the sources in a nice bibliography formatted correctly. And if I've actually entered the data for when I accessed the web pages, it will include that as well. It's quite important that I do like that. So then there's the evaluation. So I've written some summary points really about, do I think that my data supported one of the hypotheses? What did it do in terms of answering the question? How reliable is that? How confident am I that my conclusions are are good conclusions. And of course, in order to do a proper analysis of how confident I should be, I need to consider limitations of the process, not just the data collection and the equipment that I used, but also the number of data points I've got, the approach that I took with the analysis, and the reference sources that I've used as well. Any of that can be part of the limitations, and I should suggest improvements. If I haven't had time to do them, detailed improvements are important, and so this could be done in the form of a table, and lots of people do that, and I think it works quite well. But the improvements need to be specific and feasible, and I think this is one of the new changes to the IA this year, that they really specified that this sort of improvement must be something that you can actually do. And to say you're going to go and buy the fanciest equipment in the university down the road and use it for your IA is not a feasible improvement that you could suggest. But having more data values, like 20 data values instead of 12 or 8, would be a good realistic thing. But if you didn't mention how many and just said I'd like a bit more data, that wouldn't be considered specific enough. That would be a general point. And most experiments could use more data, even those done professionally. You know, often there's a limit in funding, and it would be better to have more data. So don't be general and woolly. Try and be specific and feasible. And those are the sort of things I tried to do in my report. And so there it is, 8 pages, 2,200 words. I actually wrote all of it in less than 2 hours, perhaps 2.5 hours, because I did some tidying up a little bit so that I could share it with other people. It took an hour to collect the data and have the discussion about variables. Yes, of course, it would be better to have a bit more data, so that could have been a bit longer, but certainly well within 10 hours I've written this report. And I suppose I've not had to learn how to do any of the things during the process, and sometimes that takes a bit of time for students, but I'm quite pleased. We've got something which is probably not grade 6 or 7, but it's definitely a competent IA, and the next step is to mark it and see how it does. So I think that would say that was successful writing of an IA in 3 hours.